So we are just going to start with chemical kinetics. So chemical kinetics is a branch of chemistry that deals with the study of rate of reaction, right, mainly with rate of reaction. But as we know that rate of reaction is also affected by the mechanism of the reaction, that how the reaction is taking place. So we say that chemical kinetics is a branch of chemistry that deals with the study of rate of reaction and also deals with the study of mechanism of reaction. So this is what is the chemical kinetics. So again I am repeating, just write in your copy that chemical kinetics is a branch of chemistry that deals with the study of rate of reaction and the mechanism involved in the reaction, right. So this is what is the chemical kinetics. So I think you are aware of chemical reaction now, our areas of concern, and what is the need of this thing, the chemical kinetics, why we are studying it. Now the thing is that I just want to share with you that where chemical kinetics is just playing role in a daily routine, like do you get any advantage out of it, or it is just a theoretical concept, right. So just look at the board, see this chemical kinetics is being used in many you can say in many fields. I am just going to sum up few. See, it is going to like it helps in designing the engines which are used in automobiles. It is used in designing the engines which are used in automobiles. Now see how it is used in designing the engines. See, we have got different kind of fuels, right. We have the petrol, we have the diesel, we have the CNGs, we have the hydrogen gas. So we have many kind of fuels which are being used, right. So what happens, if there is a car which works on a diesel fuel, then what we get to see in that. So what happens, that car works only when there is the diesel in the car, because engines are actually designed depending upon the burning of the you can say rate of burning of the fuel in the engines. So right, so depending upon that rate of burning of the fuel in the rate of burning of the fuel in the engines, we have got different kind of engines in which that particular fuel is being used. Suppose if you are driving a car which has a diesel in it, right, it works, that means the fuel which is going to operate in it is diesel. So if you will fill that engine with the petrol, it is not going to work, because it is the rate of burning of diesel is something else and rate of burning of petrol is something else. So that means the engine will just you can say choke. So that means different engines are just different engines are designed depending upon the different kind of rate of reaction, or it depends upon the different you can say the burning of the rate of burning of the fuel in it. So it just help in designing the engines in the vehicles. Second is that it helps in designing the fridges. Now how it helps in designing the fridges? Suppose, see, if you cook something, what happens? When you cook something, you need to store, like if you will keep it overnight, it will become stale, right? So that means we need to keep it, like we have a device, that is, we have a fridge in refrigerators at our home. So what happens? When we just keep the food items in the fridge just lower the temperature, right? So when it lowers the temperature, so what happens, you can say the rate of reaction or the rate at which the microorganisms spoil the food just slows down. So actually the refrigerators that means they are just solving our purpose, that we can just cook the food and we can keep in the fridge and we can eat in the morning as well, because they will just decrease the activity of the activity of the microorganism, that at which rate they are just spoiling the food. So we have like according due to chemical kinetics, we get to have refrigerators existing like. Third is that it is being used in the medicinal industries as well. See, we have different kind of medicines, right? So it is the kind of rate of reaction that, like if you intake a medicine, it will release certain kind of chemical, then at what rate that chemical is secreted and how it is being used to cure any kind of infection which you have in the body. So that is also depend upon the chemical kinetics. Our fourth concern is that it is used in carbon dating. What is carbon dating actually? Carbon dating is you can say a technique which is used to find the age of the fossils. So carbon dating is a process which is used to know the age of the fossils. So what happens when there is any living creature existing? So what happens? It has a C14 isotope in it. So when we just want to know that, like when that organism dies, and we just want to know the age of the fossils, what we do, we just you can say study that the rate at which the C14 get disintegrate, and this gives us the idea of regarding the age of the fossils. So this is what is called as carbon dating. So again, chemical kinetics is playing a role in it. The fourth is that, like it you can say cause the spoilage in the food items as well. Suppose we have a tomato, right? So I have a tomato here. So if I keep a tomato in you can say at room temperature in summers, so what happened? The reaction just speed up, that is the microorganisms just start degrading it, and this tomato no longer you can say remain fit for eating, right? So that means it becomes stale, it becomes rancid. But if we look at in the winters, so it remain fresh for longer, you can say for 1 or 2 days, because the reaction just slows down. In summer, the rate of reaction is something faster, that means it leads to the spoilage of food. But in case of winters, what happened? The rate just slows down. So that means we get to have this, or you can say there's less spoilage of food, right? So this here again we get to see the chemical kinetics working, because here also the rate of reaction matter. So that means the chemical kinetics is a branch which deals with the study of the rate of the reaction, and also with the mechanism at which the reaction is taking place. So as you all are familiar about this thing, the chemical reaction, and what is chemical kinetics, and what is the from where in daily routine you get to see chemical kinetics working actually. So now our concern is that what are the types of reaction. So depending upon the rate of reaction, we classify the reaction into 3 categories, right? One category we have the fast reactions, we get to see moderate reactions, and we also get to see slow reactions, right? So that means depending upon the speed that how the reactor is going to convert into product, we have 3 major kinds of reaction. One is the fast reaction, other is the moderate reaction, and third is the slow reaction. Now what is the fast reaction? So as the name suggests, fast means the speed, like it has a maximum speed you can say, or you can say it is instantaneous, it occurs very fast. So fast reactions are those which occur in short span of time, or you can say they are instantaneous. They are instantaneous. Now what reaction we get to see that they exist in this category, like which reaction belong to this category? Actually the ionic reactions, the reaction which involves the ions, are always the fast reaction. They occur very fast. So we can say ionic reaction, it is also called as ionic reactions because in fast reactions are mainly shown by the ions, right? So we have the fast reaction is also called as the ionic reaction. Now what is the reason that why these ionic reactions are always the fast reaction? Actually these reactions just you can say just involve the exchange of ions, there is no bond breakage involved. So that is why it occurs very fast. For example, I have NaOH plus HCl, I am mixing a base with acid and I will get to see a salt along with water, that is the neutralization reaction. So this kind of neutralization reaction is a fast reaction because it involves the ions, no bond breakage. As you can see that Na just displace the H and H just displace the Na, due to which we get to see a compound that is the NaCl and water. Now the second is that we have the moderate reaction. As the name suggests, moderate, so that means it is moderate between the fast and slow. So that means its rate is comparatively slower than the fast but maximum than the slow reaction. So we can say it lies between the fast and the slow, or it is a bottom line between the fast and the slow. So what kind of reaction do you get to see that is a moderate reaction? You must be aware of hydrolysis of ester. What is hydrolysis of ester? That means we add water to ester and it leads to the breakage of ester into its components from it which it is formed, that is the alcohol and carboxylic acid. So this reaction, the rate of this reaction is somehow the moderate rate. That means it is neither fast or you can say it is neither too slow. So this is actually a moderate kind of reaction depending upon the rate. Now our concern is the slow reaction. As the name suggests, that means the reaction is going to occur very slow. That means you will mix the reactant and you are going, definitely you will get the product, but it will take time. The reaction is going to occur at slow rate, right? So what kind of substances show this slow reaction? Actually, the molecules show this kind of reaction. That is why the slow reactions are often called as molecular reactions. So what happens? Actually, the slow reaction, what happens in it? The old bonds just break up and the new bonds are formed between the constituents. So it takes time. So that is why it appears to be slow. And you know, some reactions are too slow. That means when you just add substance, when you add reactants, you get to see nothing happening. So that means it appears that the reaction is not taking place, but actually with passage of time we get to see that yes, the product is forming, but the rate of reaction is something very, very slow. So the example is that the rusting of iron. As you all know, like if we keep iron in moisture, what happened? The rust color layer is just going to deposit on it. That means the rusting is going to take place. That is the formation of the thin layer, that is Fe2O3.XH2O, that is rust. So rusting of iron, like if you bring some iron article from the market and you just start using it, you don't see it don't get to see a rust layer in the beginning, but in few years what happens, you get to see that the fresh iron rod just became you can say a rust kind of layer, a brown flaky layer just starts depositing on that, and this is actually because you get to see in many years, it takes actually many years to occur. So that is why it is considered to be a very, very slow reactions. So according to the rate of reactions, we have reactions as fast, as moderate and as slow reaction. Now the question must be striking in your mind that what is the reason that so few reactions are considered to be fast, few are slow and few are moderate. So you should be aware that chemical reaction actually involves the breaking of bond and forming of new bond, right? And for breaking the bond we need the energy. That means we need to supply energy from outside, but in forming the bond, when we need to form the bond, energy is released along with it. So that means when the reaction is taking place, different reactants combined with different speed, or you can say the different reactants when they just start reacting with each other, the rate at which the bond will break or the rate at which the new bond will form, that, or you can say the rate at which the energy is absorbed or the rate at which the energy is evolved is different for different reactants. This is the reason that few reactions are fast, few are moderate and few are slow reactions. So depending upon the rate, I think it's clear that it is just a matter of you can say the rate at which the old bonds are breaking up and the new bonds are forming up, or the rate at which the absorption of energy is taking place or the evolution of energy is taking place, because this has to occur, right? If it won't occur, then the reaction is definitely not going to take place, because the reason behind the chemical reaction to happen is that the reactants need to break their old bonds and form new bonds, right? To form new length, they need the energy, and they will also means there will be energy changes taking place, and this will take time. And in case of few reactants, the time is going to be very small, that is around you can say 10 raised to power minus 14 to 10 raised to power minus 16 second. So instant, right? And in few reactions it will take many years, as I told you about rusting of iron. So that means obviously according to the rate of reaction, we cannot classify the reaction into one type. We have the three different types. So I think you are clear with it. Now we are going to start with the next topic.